Hello, I'm going to go over EdgeDB real quick. This is specific to a class called Knowledge Engineering taught at Northwestern. I'm just trying to get people up to speed so that they can get started using EdgeDB. Here's the main website for EdgeDB. It's actually based on PostgreSQL as the backend, and they've kind of just completely rewritten the way that SQL statements are structured and made their own query language, as well as supporting GraphQL within EdgeDB, at least for the selecting of things. This is kind of like a hybrid between a graph database and a traditional SQL database. It's kind of the best of both worlds. It's still fairly new, so a lot of this will probably be outdated by the time anybody else watches this, but we'll see what we can do. So for installation, there's two. You're either installing it on Windows or you're installing it on the Mac OS or Linux. For Windows, I will note that this is in PowerShell, so you will have to open up PowerShell. It will not run from the traditional Windows command line. You have to run this command in PowerShell, then it will prompt you for how you want to go about an installation, and you're just going to do the default installation. Very simple, very straightforward. It's basically the same thing on Mac OS and Linux. You run this command, it prompts you for the same thing, and it's basically installed and pretty much works from there. You can do a lot more with it on server stuff. We're not going to concentrate on that. We're going to assume that you're running this locally. Future versions of this class, they might have something set up on a server to where we'll be connecting to servers more. But for now, I'm assuming that you're installing this locally and running this locally. So I'm thinking that you can figure that piece out on your own, and I don't want to reinstall it on the system that I'm running it on. So you guys can do that on your own. Kind of walking through the structure here, this is probably the most radical compared to any of the other databases that you might be familiar with. It's definitely different than Neo4j and Cypher on how they structure creating the tables and the relationships. It's more graph-like than the SQL languages, and it's really nothing like a document database. So this piece over here is how you actually write essentially the definition of the schema of the database. And as we can see over here on the right-hand side, we can see what that will end up looking like. And so in this case, we have the nouns, the main things that we're storing information on. Like we have movies, we have shows, we have a person, and then a movie will have actors in it, and actors are part of person. And as you can see, you can also store characteristics on relationships. So that actor plays a specific character, and that character is associated with a real person that's in the persons table based off of a name. There's also some more abstract things that you can do within the EdgeDB. One of those is content. So what they're basically saying here is that for movies and TV shows, there is some universal fields that are common across both of those, like the ID and the title, and actors are common across both shows and movies. Now what's different about movies is movies has a release year for that movie, and shows has number of seasons, which are unique to those specific nodes or attributes. So even though we have a generic thing here, we can get more specifics here. For the most part, I'm going to recommend that we stay away from this abstractness. It's just going to make your queries slightly more complicated, and when you see that you need it, it's fairly easy to migrate to a new database structure and take it from there. So you might be able to modify the schema from there. Along with that, we also have specific database things that you might be used to. So we can put in default values when you insert in a record. We can add in constraints. So this could be that a specific value has to be unique, or it has a minimum value of 0 and it can be greater than that. We can put in indexes to make the database run faster. So if you're always querying on a specific field, you can add an index to that field and make it run faster. For the most part, we won't probably need to do too much of this. A computed field is useful for some things. Default values are useful for some things. Constraints are definitely useful, especially for primary key like attributes, like a specific ID or something that's coming from an external system. But for the most part, I would say just know these are here and use them as needed. Otherwise, you can kind of ignore that. The next piece that's kind of hard to understand if you're coming from other database technologies, EdgeDB has created a lot of concentration and focus on migration. So unlike the Neo4js, where you kind of make up the structure of the database, the attributes that you have with specific nodes, on the fly, you can add them and remove them basically however you want to. EdgeDB definitely wants all of that stuff defined. But to combat the difficulty of adding a new field, subtracting a field, changing a field's type, they have created a migration actual utility that kind of will take the changes that you made to your schema and it will apply that for you and make sure there's not any problems when it goes to apply those schema changes. So when we define the actual schema, then we can tell it to create a migration event and it will write all of the SQL statements that we need in order to be able to run to do that migration well and not have any issues. Okay, now that we've went through that, I kind of want to overview what are some of the pieces that you're going to have to know and use and understand the difference between. So if we go to a command prompt now, and we go open up a file explorer, and what we're going to do, since most of this is locally, is you're going to want to create a project folder somewhere on your computer that you're going to use specifically for EdgeDB and any other Python or Go or any other coding things that are going to use that EdgeDB instance. We're going to want to put them all in the same folder just to make things easy so we don't have to worry about connection strings. Are we in the right database? Are we in the right file? Are we in the right project? All of that will be handled if you just do everything out of the folder that you're doing. So for that specific example, I have created a KE EdgeDB example folder, and there is literally nothing in this right now. So if I was to go try to run EdgeDB here, we're going to get an error. So let me show you what that means. So in the command prompt, if you type EdgeDB, you will see that we get an error message. So basically, how EdgeDB works is you need to initialize a project, and all of the information about that project will be stored in this folder that you are creating the project in. We can also see that since I've been playing around with this for a while, if you're not entirely sure where you've set up your project or if you have a project running already, these projects EdgeDB calls instances. So if we type in EdgeDB instance list and hit enter, you can see all of the different instances that I have set up on this particular computer. It will also tell you the port address, which may be useful if you have to manually connect to one of these instances yourself outside of the actual folder. Again, the best bet is to just store all of your code, everything in that specific folder. Makes things a little bit easier for everybody involved. So we want to make a new instance. We want to make a new project. So we will literally just do EdgeDB project init. And you're not naming the project here. It's just project is a keyword. So let's type that in. Okay. And so it's going to ask us a few questions. Do you want to initialize a new project? Obviously, yes, because that's what we're doing. So yes, and then specify the name of the EdgeDB instance. I would recommend that you do what I'm doing here, which is I'm going to name it the same folder as what the parent folder of this project is. That way, I can just look for Graph Movie DB or Knowledge Engineering Example or EdgeDB Test or Test. That specific folder will be where the EdgeDB information is for that entire instance, that project. So we're going to keep that. We're going to say that that's the name that we want. We're just going to use the latest version of whatever EdgeDB has. For right now, I don't think that this makes much difference. 2.5 is what I currently have as the newest one, so that's what we're going to use. And now it is initializing the EdgeDB instance. And you'll notice that we already have some folders and files that have been created over here in the folder where we're initializing the project. Okay, so now as we can see, it said everything is up and running and everything is good to go. It's telling us to run EdgeDB. Now, I got confused the first time that I was doing this, so there's a couple of different things that this EdgeDB command line interface does that running EdgeDB or the command line EdgeDB version doesn't do. So if we type EdgeDB, you'll notice that this has now changed to kind of a different prompt. And this EdgeDB tells us what database we're in. By default, EdgeDB makes a database like this. Within this command prompt, there are some things that I cannot run. Like I cannot run a migration from here. I need to run EdgeDB migrate, and I cannot initiate or initialize a new project from this command prompt either. This is like I'm actually interfacing with the database itself, and this is kind of like my command line within this specific database, within this specific project, to be able to run normal commands like that. So what I want to do right now is we're going to quit out of this, which you can do with /quit and hit enter. And now you'll see I'm back to a normal command prompt. Okay, so unfortunately, one of the best ways to define the schema is literally with a text editor, and you can't really do it within the EdgeDB UI. The EdgeDB UI you're going to find is very useful, and it's very similar to Jupyter Notebook for Python. I think a lot of you are going to like interacting with the EdgeDB UI as opposed to typing in commands here, or even in many cases as opposed to writing the code in Python or in Go to interact directly with the database. But to define the schema and to migrate that schema into the current database, we have to do that through a text file. So if we look here, we've got an EdgeDB TOML, and we've got a DB schema folder. So what I'm going to do is, for me, I'm going to use Visual Studio Code because it has some EdgeDB plugins, as well as is pretty good at just being a general text editor. So we're going to open this folder in Visual Studio Code, and we're going to define our schema in Visual Studio Code. Okay, so I have opened that folder in Visual Studio Code, and you'll notice over here we have the TOML file, which for right now doesn't really tell us much. If you're actually doing this in a production environment, this will tell you where a lot of your server connections are, like the server address, the port number, etc. will a lot of times go in this EdgeDB TOML file, but for now we can just ignore it and just realize that that's what that is. What we want to edit is the ESDL folder. So this file. This is what defines the schema and the layout for all of our nodes and all of our relationships between all of our nodes. And once we're done with this, This file is what EdgeDB, that command, will use to create a migration event, which will be actual SQL statements that it will run against the database, the EdgeDB database module. Okay, so modules are another way of separating out things that aren't related to each other. For our purposes, since we're creating a knowledge graph that's fairly narrowed, everything should go into the same module. And this is where things get a little bit weird because you have projects, you have databases, you have the modules, and all of these things are kind of just ways to break things down into smaller chunks, but it's really easy to get confused onto what's doing what. So for our purposes, we're just going to leave them into the module default, and we're going to put in our definitions here. Going back to the EdgeDB website, you will want to look into a fair amount of detail on how the schema modeling works. So at this point in the page, this is an actual schema definition right here, and we can learn more about schema modeling by clicking on this. And then this will bring us over data types, abstract types, default values, etc., the type system that we have for what types of attributes we can store things as, how the relationships work. We have one-to-many, we have one-to-one, we have many-to-many, and we have backward links. In my case, I'll kind of go over the most common of these as I'm going through it. Use the tutorials for EdgeDB. It's going to be a lot more intuitive than what I'm going to go over. I'm just trying to get you started so that you can get into things quickly. And obviously, there's a lot more advanced stuff that you can do. But for right now, this is a great resource. This is probably where you're going to want to go. I'm going to talk through my understanding of it, but I would definitely say go back to this website for the actual real information on how these things work. Okay. I have taken what I'm considering to be an okay starting point for what my schema is going to look like. So I have a number of what I'm going to consider nodes or nouns if you're talking about the graph database type of terms. So we have movies, we have TV shows. Within TV shows can have one or more seasons. Movies and shows can have one or more person acting in that particular show. And then we have accounts. So the accounts would be like somebody who has a Netflix account and watches particular movies, rates particular movies, etc. We can have that in there. So let's go over the movie first, since this is going to be one of our more robust types for what I'm doing for a movie database. So we define each one of the nodes or tables, the main thing that we're modeling, as a type. So this type is a movie, and it has specific properties. In this case, I'm making this a required property. So that means that it must be filled out. If it is not, the database will return an error. So we have a required property. These are like attributes or columns in a traditional database. And this is going to be called title. And it is of the type str, which stands for string. So it's just a generic string type. The next property is release year. This one is not required, so you could enter in a movie into the database that does not have a release year. And this one is being stored as an integer, and it's a 32-bit integer. There are other integer bit types as well. If you need a bigger or smaller integer type, that is a selected option. And I think as EdgeDB goes on, you're going to have a lot more data types available. Right now, compared to Postgres, it's fairly limited. Okay, the next part, and this is where the graph database the graph database part of EdgeDB kind of starts to come in. So we have a multi-link. And what multi-link means is that it's a many-to-many relationship, basically. So we can have many actors on this movie, and each actor is tied to a person. And the person relates to the person type. So that's how this works. So in this particular table or node, it will be listed as actors, but those actors are coming from the person type. And we're going to have the connection between the movie and that person has a property associated with it. That relationship is a character name. So if a specific character like Scarlett Johansson, she plays Black Widow in a lot of the Marvel movies, so the character name could be Black Widow, and that would link up to the person Scarlett Johansson in the person table. And so that's how we could see that relationship, if that makes sense. Okay, shows is almost exactly the same as movies. We can see that title is the same and it has a required property. We can see that it has the same actor link. What it has different is instead of release years, it has the number of seasons. So this number of seasons is actually a calculated field. So this is calculating the count. And here we have what we consider a backward relationship. So we are counting the number of shows that is in seasons. So what this will do is if you have Friends that's made up of 10 seasons, it will go and look in the seasons table. And if we have listed season 1, season 2, season 3, and season 10, it will say 4 because we're missing a number of the seasons in the middle, but we're not summing those or doing anything else. It'll just say that we have 4 of the however many seasons we have. So that's what that is. Okay, so seasons is a really simple table here. This one is just a number, but this has a required link. So we cannot have a season unless there is a show tied to that particular season. So if I go to insert a record in seasons before I've made any shows, I cannot do that because there is a required link between the two, which is what that does. And we can see that in this case, the relationship linkage goes from seasons to show. And that's why this one has a backward relationship to get back from shows to show up, or from seasons to show up in show. Okay, the person is relatively straightforward here. So we have a required property called name. And here we have links, and these ones are backward links again. And this will show every single movie that that person is in. This one will show every single TV show that that person is in. And that's all automatic when you're defining the relationships. These just come over for free because they're part of the relationship, which is just awesome about this. Okay, if we go up to account, here's another useful constraint situation here. So we have a required property called username. And in this case, we're going to say that there cannot be any duplicate usernames. It has to be exclusive. So if we try to insert the same username twice, we will get a database error and it will error out on us. We have same things that we had below where we have a required property. You'll notice that we have 2 required properties here. We have an email here. We have property age. Here's another type of integer. So we had integer 32 here, integer 16 here because age shouldn't go up as high as what release year potentially could. And then we have a property just to show another data type that you could have, which is active. So this is a Boolean, so this is true or false. So either the person is active on the site or they are not active on the site. And then this multi-link situation here is very similar to the link situation here, except in this case, it's a multiple situation to where the person will have a movie watch list and they could watch. This is all of the movies that that particular person has watched and all of the shows that that particular person has watched. So that's what we have right here. We could define these in multiple ESDL files, but for now, I'm just going to define it in one file. If we make any updates to this, the migration situation that I'm going to show you makes it really easy for you to add columns, remove columns, etc. So let's save this file, and then we're going to go back to the command prompt. And I'm going to open up migrations just so you can see that there's nothing in there right now. So there's nothing in there on Visual Studio. And if I go to that particular folder, that one, this one, we can see that there is nothing in the migrations folder. So if I go back to our command prompt, what we want to do now is we want to do a migration event. So we've created the schema, but we have not actually loaded that schema into the database itself. So if we go back to the database or the Postgres or the EdgeDB tutorial here, we can see that we've created the schema, which is what it's showing down here. And now we need to run the migration event. So we've created all the properties, we've defined this. Now we need to do EdgeDB migration create. And you'll see that it will create actual files that will be ran. And then we can see what's going on here. So let's go see what happens when we do that. EdgeDB migration create. Okay, we can see that it created something is what it's telling us. And we have an ID here. And so let's go look at those folders and see what it actually created. So it created in the migrations folder an EdgeQL file. So if we open this with Visual Studio Code now, you can see that these are actual creation EdgeQL database statements to actually create our entire schema for movies, for people, for shows, etc. Even the relationships are all involved in this. So now what we want to do is we want to actually run the migration. So you'll see that the next command that we need to run is EdgeDB migration apply. So if we go back here, we type in EdgeDB apply and hit enter. It says that it has applied that migration. So now that we actually have a schema defined, now we can open up the EdgeDB UI, which is where I'm thinking that most of you will do most of your interaction. So if you type in EdgeDB UI and hit enter, it will open up a web browser for you that lets you interact with your specific project. So in this case, my instance or project is KE EdgeDB example. And we've got in a default database that's already here, which is EdgeDB. And we could even create an example database or create a brand new database in this user interface environment, which is nice, but we cannot define the schema in this UI environment, at least not yet. So if I click on the EdgeDB, we can see that we are now in EdgeDB. And because I have a schema defined, it lets me browse the schema, browse data, or open the REPL, and the REPL is basically your command line to be able to manually from the command line run EdgeQL statements. So let's browse the schema and see if it looks like what we're expecting. So we can have a text or a graphic display, and we can switch to just the graphic. We can switch to just the text display. Let's do text and graphic. And here we can zoom out a little bit. So we can see that we have a movie node, we have an account node, we have a person node, we have a show node, and we have a season node. And as you could kind of see that we've got some connectors there. So if I click on movie, we can see that this actor, this link, actors, has an attribute of a character name, and that links to person. If I click on person, we can see that person has two links, one that goes to movies and one that goes to shows. If I click on shows, we can see that there is a link between the character name and the person, just like with movies. And if I click on season, we can see that season links back to shows. And then account will have either the movie watch list or the show watch list linking to the specific attribute or the specific nodes here. And so that's what we have going for us right now. I am going to click on the create example database so that you can see what another database looks like. So if we click on that, EdgeDB will create a movie database schema basically for us that's kind of based on their tutorials that they have. Now if I go back to the KE EdgeDB example, we can see that now I have two databases up here, and I could create another one right here within this project instance itself. So if I go back to here and I go to browse schema, you should be able to see that it is very similar to the schema that we had before, but they've got more abstract situations with content specifically. Okay, if I go back here, we go back to our EdgeDB and we go to browse data. This will let us interact with the data. If I click on that, we can see that in our database, there is nothing populated. There's nothing in shows, there's nothing in seasons, there's nothing in person, there's nothing in movie. We go back to the example database and browse the data here. We can see that the accounts has some information with it. The shows have some information with it. The movies also have some information with it. Okay, so let's interact with the example database for now. And then after this, I'm going to go in and show you guys how we can populate this database with either Python or with Go for just some examples there. And I'll try and run through that fairly quickly so that you can kind of see the code that we have. So I would recommend interacting with the database in the GUI user interface first, just to make sure that you understand what's going on and can kind of interpret what it's doing. So the nice thing here is that if I want to insert a new movie, I can do that visually in the GUI. So if I click on Insert Movie, you'll see that there's a space for title. The ID will be automatically populated. I can put in a release year, and we'll show you what it looks like to add an actor. So for title, we're just going to say test. Click the arrow button. For release year, we're going to say 1998. Click the green button. And for now, I'm not going to add any actors. So I want to review the changes to see what this looks like. So if I hit review changes, this will show you the EdgeDB EdgeQL statement that is going to be ran to insert that specific record. So we're running insert 0, just as an iteration here. We're inserting into movie. We're inserting the title, which is a string type, The value for that is test. We're inserting the release year, which is an integer 32 type. The value for that is 1998. If we hit commit changes, we can see that that has now come up. Okay, if I wanted to add actors to this, I could click on this. And it's going to bring me over into the actors situation. So right now, there aren't any actors for this movie. If I click edit links, it will come up with checkboxes in this case to where I can add individual people. So I'm just going to select 3 random people, and then we will review the change. Okay, this one is not an insert. This one is an update because we already have that movie. It exists. It is filtering for that specific movie based off of the unique identifier that EdgeDB has set up. And it is setting actors in this plus equals means that it's adding to, as opposed to removing or overwriting what's in there already. So if we already had actors in here, it would just add these actors to it. And we're going to select from the person, and we're going to pull over these specific IDs to pull in these specific 3 people. And let's commit the changes. Okay, now we can see that. Let's close the edit mode. And now if I go back to movies and I look at that movie, we can see that there's 3 people associated with my test one. If I click on that, you can see the 3 people here, right? Which is fantastic. Okay, let's go back to our EdgeDB, the one that I created. If we browse data, we can do exactly the same thing, right? So let's insert a movie into ours. Let's insert a movie that I have ready. So we are going to insert my movie. Always forget about the green arrow. So we're going to insert my movie. We're going to click the green arrow to acknowledge it, right? This one released in 2017. We're going to click enter. We can review changes. We can commit changes. Boom. It's going to add in the movie. Okay, let's insert a second movie. And we're going to say that it was released in 2022. I'm going to click that arrow. We're going to give it a title of my second movie. We're going to click that. Review changes, commit changes, boom. We've got the 2 movies added in. Okay, we try and add actors, but there's no actors to add. So let's undo that. We'll go back to person, which is where actors actually show up in. And we can see that here, that it's coming from person. So we go to person, we can insert person, and let's insert John Doe. Insert John Doe, hit that movie. The movie filmography and show filmography will come over by default automatically, so we don't have to worry about that, but let's insert another person, right? So I can click this again, and we can add in Jane Doe before committing any changes. We can review the changes, and now you can see that it is running 2 separate statements to insert 2 separate records on one commit. We're going to commit those changes. Boom. Now we have actual people in here, John Doe and Jane Doe. Let's go back to movies. And let's go to actors and my movies. We'll edit the links since that's a link. And let's add John Doe and Jane Doe to that movie. We can review the changes. We can see that it's updating the movie. And this program's able to use the UUID, so that's how it's filtering by ID and that user ID. And we can commit the changes. Boom. Now we've got 2 people in there. Go back here. We can see that there's 2 people there. We can click on my second movie. And let's edit the actors in my second movie. Edit links. We'll only add in Jane Doe this time. Review changes, commit changes. Okay, And now we can look at this and we can see that Jane Doe has 2 movies in her filmography. John Doe only has 1. And if we click on this movie, we can see that these are the 2 movies that that particular person has been in. And vice versa, we can go back to movies themselves and look at second movie, and we can see what individual person was on that second movie. Okay, let's go do a handful of shows here. So let's insert a show. And I want to insert the show Friends, is what we'll do. Okay, and let's add in an actor while we're here. And you can see that in this case, it is inserting the show and the actors at the same time as an insert, not as an update statement like we were doing before. We can see the title of the show is Friends, and it's also adding actors and selecting that specific actor to add. We can hit commit changes, boom, it's in there. We go back to Friends, and we can see that it has 1 actor there. However, it does not have any seasons yet, right? So let's go to season, and let's insert a season. And Friends has season 1. Click that. And let's try and commit this without adding in a show. If you remember by the definition, show is a required field. So let's see what that looks like. See, in this case, the GUI will yell at us and tell us that we were missing a required field, which is show. So we cannot commit the changes. However, if I did this as an error, I could clear all changes, which I'll click, and you can see it just goes away. So let's insert a season. We're going to insert season 2 this time, and we're going to click on show, edit links. Friends is the one that we're doing. Let's review the changes, and we can see that now we have the season, the number, it's the second season of the show Friends, which is based off of this user ID. We can commit changes here, and we can close the edit mode and go back. And now we can see that this particular season, season 2, has the show Friends as the show. Now let's insert another season, and let's do season 1 of Friends. And we will commit the changes, and we'll go back to here. And now we can see that we have season 1 and season 2. Both of these are for Friends. So if I go back to the shows, we can see that it has 2 seasons, which is just a count of the number of records that are in that seasons table or node for Friends. And so that's what that is. It has 1 actor right now. Let's add in another show to show you a unique thing about the seasons. So if we insert the show Game of Thrones, and let's just set an actor for it as well. Hit the links, Jane Doe in there, review changes, we will commit the changes, go back, we'll go to show, we will go to seasons. And now let's add in a season of Game of Thrones. The infamous season 8. We will click that. Let's click on show. Let's edit links. You'll notice that instead of the checkbox, these ones have circles. That's because I can only select one of them, which was how we defined the connection between the 2 tables, is that there is only one link between them. It is not a multiple link situation. So each season can only be associated with one show. So in this case, we'll associate it with Game of Thrones, review the change, commit the change. Boom, we're done. Back, and we can see that now in shows, we have Game of Thrones. It has 1 season. Friends, we currently have 2 seasons. And we can click on the person, or we could go to the seasons to see what show numbers those are associated with for the show. Okay, let's show what account looks like since we had slightly different types in the account. So we will insert a record for the account. So active is a Boolean, as we can see. So this is going to come up as true or false. So we're going to say that this user is active true. This one has an age. So if I try putting in a value that's not an integer, you can see that it's not going to even accept it. And then if I put in 18, we can hit enter. For email, email is not smart, right? It is just a string type. So I can literally put in anything that's a string and it will accept it. Username, so let's put in a username of user1 and hit enter. And let's review the changes and we will commit the changes. Okay, let's insert another account and let's try and do user1 again, right? Email, we'll just do an email. Age, we'll say 16 this time. And active, we will say true. And let's review the changes. And it looks like it's going to accept it. So let's see what happens when we commit the changes. See, now it's yelling at us saying that the username violates an exclusivity constraint. In the Python and in Go, you can actually check for this with a EdgeQL statement to where if it violates a exclusivity constraint, you can have it update the record instead of insert the record, which is really useful so that you don't have to double check to make sure that the movie or the whatever already exists. So we're going to clear all changes just so that we can see that. So that's basically what we've got for the EdgeDB, for the example that we created, and for the schema that we ran. Okay, the other thing that I want to show real quick is you've been fooling around with this for a while and you realize that you need some other attributes or you need to add in another table, etc. So let's show you what a migration event for adding in a particular attribute will look like. So in this case, we need to go back to the folder and change our schema is the first step that we're going to make. Okay, we are back in our Visual Studio Code, and we're back looking at the default ESDL definition page. And what I want to do here is we're going to remove the property age from the account, and we're going to add a date of birth attribute to it. So first of all, let's add in a property DOB, date of birth. And this is going to be a calendar type local date time. You can check EdgeDB to see what types are available. That semicolon there. And let's remove the age because now we could potentially calculate the age based off of the date of birth. So if we remove an attribute and add in an attribute, let's see what happens when we save this. And then we need to create a new migration. So we'll do EdgeDB migration create. And it's prompting us to make sure that we didn't do something stupid. So did we drop the property age? Yes, we did. So let's say yes. Did we create the property DOB? Yes, we did. Okay, it created a new migration event. So now we need to tell it to apply that migration. So we're going to do EdgeDB migration apply, hit enter, boom. It's already applied. That did that super fast. Now we may have to close out of our EdgeDB example here. So I would recommend that if you do a migration, just to be safe, close out of your GUI and come back and relaunch EdgeDB UI. Okay, and then let's check out our EdgeDB. Let's browse our schema. Okay, and then we can look at account and we can see that it now has date of birth and it no longer has age listed there, right? So let's just go in and look and see what account looks like now that we changed that. So if we go back to Data Explorer and we look at account, now we can see that there is a date of birth column. So if I double click on this, we could do the date of birth. Okay, next I'm going to walk you through the Python specific code that I ran through in order to work with the EdgeDB once you've defined the schema. So you will have to define the schema first before you can start doing this. So I'll jump over to the folders and start showing you what that looks like. Okay, I'm going to primarily focus on the Python specific scripts that I ran through. I'm not as comfortable with Go as what I should be, so the Go is pretty light on how robust it is. The Python one was what I was more comfortable because I deal with Python way more than what I've been dealing with Go. So within the example code that you have, there is a EdgeDB Python example Jupyter Notebook file. So here I'm bringing in some basic things. So I'm bringing in pandas in order to be able to import the data that we extracted from our APIs or from web scraping or from wherever you're getting your raw data from. Probably easier to do it in pandas. I don't know that I'm using JSON here, but a lot of your files may end up being JSON, and you're also probably going to be using JSON in the EdgeDB situation, so you're going to want to have JSON in here. I'm not actually using regular expressions, but you might need to do that to clean some things up. Date, time, and time are just useful utilities depending on what type of data you have. And then you're probably going to have to pip install the EdgeDB module. And there's some good documentation out there for the actual Python client in order to be able to interact with stuff. The way that I have done this is I have saved all of this in the physical file where our DB schema and where our EdgeDB TOML file was. So this is where I initialized the project for EdgeDB. It makes it way easier to do a client connection. So you don't have to add in any parameters here at all. You just have to create the client in order to be able to connect to it. Really good. Here's some other references if you need to either directly connect to the client or if you want to connect to a server using a DSN. That's another thing that you can do. And down here further, I do have some of the variables that you could potentially throw in here. You could change the database, you could change the timeout, you could change the username, the password, the port, the host, and the DSN. All of these are variables that you can call when you're creating the client. To make yourself easy, to make it less error prone, I would just say your best bet is to save whatever Python script or Go script you're going to be running in the actual folder where your EdgeDB project initialization was at. So this first section here I can actually run through because this is based off of what I manually created after we defined the schema. I manually created some of these database entries for movie, and we're basically pulling out what was in there from before, and we can see what that actually looks like. Let's go ahead and run through the code just to show you what everything does. We're going to initialize everything, which shouldn't cause any issues. We're going to create the database connection client. We're going to do client.query, which is the main thing that I used for Python. For Go, there was a few different examples, not just query, so you might need other ones. But we're going to return this into a response. When I initially was doing this, I thought it was returning into JSON. It is actually not a JSON type. and we'll see that here in a second. So we're going to return that into a variable. We're going to print off what that variable looks like. And you'll notice that it has an object. It has some brackets showing that it's got at least a list part to it. And then it's got some dictionary-like elements in the middle. But it's kind of unique in that it is not how Python usually displays things, because it has this colon equals. This is very specific to EdgeDB on how it's returning. And if we see what that is, it is actually coming across as a list. And if we go and grab the first element of that list, we can see that it is a custom defined object from EdgeDB. But we can return specific properties here. So what we're going to try first is we're going to try title, and we're going to see what happens. How I initially thought that you needed to pull things. You can see it doesn't like it. It wants us to use property title should be accessed via dot notation. So what that basically means here is that we can do the first element of that list dot title. So if we loop through here, we can see that we have printed off the movie title, which we're only getting one movie in our entire list, which we could go back up here and see there's only one user ID for the actual movie title. This object is actually for our actors. So we've got JSON response.title, and then within this we have a set of actors. We go back and look at the actual file, you'll notice the title is fine, and then actors is another list of objects, right? So we're going to loop through everything that's in actors. And within actors, we want to return their name. So we can see that this was the movie, it was my movie, and it has the actor Jane Doe and John Doe. And then just to clean things up, we're going to close the client to make sure that it doesn't have any issues. And now this time, we're going to connect to the example database. So this is going to have different and more data in there. Ironically, the example database also has a movie client or a movie table, so we can see what happens when we connect to a different database. So if we pull in the first response, you can see that this first response is Ant-Man, as opposed to, in our case, when we were running the same query, the first response that we got was my movie, because that was what I put into the database. What EdgeDB puts into their default database, or their example database, is Ant-Man. Okay, and then let's close the client again, just to see what we can do. Okay, now we're going to get into more of the specifics of what you can do with the EdgeDB client, and how you can run insert statements, how you can run update statements, how you can query other information, etc., and kind of just how to use this within Python. So here's a basic one where we're going to insert a new movie, right? We're going to insert the movie called Test Movie for the year 2021, and you can see that this is the main SQL statement, and then after it we do comma, and then the $sign is associated with the variable name that we have here, and same thing for this. So we're going to enter in a title of name and a year for the release year, and we enter that, and we can see it just returns a object. So let's query for the movie table, and we want to return the title, release year, actors if it has any, and the actor information that we're going to want is the name of the actors. And we're going to apply a filter where the title equals name, and we just manually put in test movie just now, so let's see if it's in there. It is, and there are no actors. Kind of makes sense. Okay, insert a movie and actors at once. So this one's an interesting one to where you can insert into what I would consider more than one table because of how the graph database situation works. So we're going to insert into movies. We're going to insert what title. It's going to be test movie again, which is interesting. And then we're going to insert actors with this as well, where we're going to grab specific actors' names. And in my case, I don't know the unique user ID, unlike what the user interface tool, when we were manually inserting records, it used the UUID. I don't know what that is, so I'm just going to filter for specific names, and I know that John Doe and Jane Doe are both in my database, so we should be able to add them. So if I run that, it didn't give us an error message. It returned us an object, so it should have worked. Now if we search for that particular movie name, test movie again, we can see what happens. And we can see that there is actually a duplicate here. We have 2 test movies. And interestingly, although I thought it should have worked, we did not get actors into either of those. I might have to troubleshoot that later. But like I said here, this creates a duplicate movie. So instead of inserting a new movie, we need to update the relationships is what we need to run instead of just an insert. So here's a query in order to be able to delete. So we are deleting the movie when the title is test movie and when the release year is 2021. So that is the one that we just inserted. Back up here. Let's run that query, and then we'll run the select statement again, and we should see only one movie this time. Okay, and this actor doesn't actually exist. Let's grab an actor that should exist. Okay, so now what we're going to do here, which this is going to error out on us, so I'm not actually going to run this. This is useful if you have on a specific constraint that says that you cannot have duplicate titles. So in my particular database, I do not have a uniqueness constraint on the title. So this will actually error out because you need to do the conflict only when it has a title. So how this is useful is it will insert the movie if the movie doesn't exist. If the movie does exist, assuming that we had the right constraints, it will run an update instead and update the actor's name. Okay, so we're going to skip that part. Okay, so down here, what we want to do is we're going to run an update statement. So we're going to update the movie where the title is test movie, and we're going to set the release year to 2022, and we're going to set the actors to John Doe. And then we're going to select this out, and let's see if we can return out what we're expecting. And again, I don't know why the actors are not up. Okay, and then these next pieces, this one acts you through if you want to add instead of overwriting. That would be the plus equals is what you want to do here. And then if you want to remove a link, you do the minus equals in order to remove the filtered link. And then this is one thing that was somewhat painful. So the relationship attribute character name is not that easy to return correctly. So you can return it and you can print it out in the object itself relatively easily, because you will see here that the character name the hero, is coming across just fine in this result. Now, if you try and extract it out, it doesn't come across as well. I think I actually do that later, so we won't worry about that. Okay, the last thing that I kind of want to cover is a bulk update utility. So a bulk upload utility. So EdgeDB has the ability to parse a JSON file and bulk upload information into the database. So let's go ahead and let's see a few examples here. So I have a movie sample, I have a cast sample, and I have a cast sample JSON. So the nice thing about pandas is it can read JSON, it can read CSV, it can read pickle files, depending on what you're bringing over. It can read all of that, and then you can kind of see what we have for the data in here. So here's what data we currently have for the movies. Here's what data we currently have for the cast. And both the cast examples are basically the same thing. It's just one is a CSV, one is a JSON. You're probably going to have to clean up what data you're actually going to put into EdgeDB. So that's kind of these next steps of, we're going to take the release date and we're going to extract out the year, because in our EdgeDB, we're only doing the release year, not the release date. We're only doing specific columns. When we export it, we need to add in, because it's a JSON file that it needs, we need to orient it on records. If you don't do this, it will not load into the EdgeDB correctly. So there's that. And then we read in the JSON file. EdgeDB is expecting a string, so it does not want the Python dictionary type. So even if you do JSON loads to look at it to make sure that it looks correct, you really need this to be in a string, which is what JSON dumps will do. It will convert this to a string where it is just text. That is what EdgeDB is working with. And then we come down here, and this is the format for the bulk upload. So with raw data, and the raw data is JSON, and that's $data is our JSON string that we just got from importing that in. And what we're going to do is we're going to loop, which you have a for statement that lets you loop within the EdgeDB query client. And we're going to loop over this JSON array unpack the raw data, which is this. And this is just the format that we do. It's union, and then here's what we're inserting. And in this case, for the person table, all that we care about is inserting, or the item, because that's what we're doing here, we're inserting the name, which is the name of the person here. And let's just show you what that JSON file will look like for the person to load. So that will be person to load. So here you can see that every single entry has an ID and a name, and we just want to load in the name from the JSON data. Okay, and then we can do the same thing for other tables. So for movie table, we can insert the title and the release year, which are both coming from the movies to load JSON, which just has the title and the release year. And that's the name of that. That's the name of that, which is title and release year accordingly. And then finally, we can do the same thing to any other table, like the characters, etc. And here's one where we're actually, instead of running an insert, we could do all of the relationships now that we have the people and the movies loaded in, and we can update the movie table. We can filter for a specific title, and then we can add in, which is what this plus equals is, an actor based on the actor's name and the character, and it will return out. And then we can just run a select statement on all of this to see what it looks like. And then here is the, and then here is a final statement just to kind of print things off. I'm apparently doing the linked attributes incorrectly, but I don't know how to do them correctly, so it works. So we're going to do that for now. So that's all I kind of had to share. Hopefully that helps everybody. Thanks.